Hello, everybody. It's great to be here one more time today. My name is Gary Feller. I'm the CEO, president, founder of GSD, Get You Done Venture Studios, premier AI and quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team at Click Software, which is sold to Salesforce for $1.35 billion. And also Eva.ai, an AI HR tech company co-founded with Dr. David Yang. We believe at GSD, Get You Done Venture Studios, and intellectual capacity is evenly spread, but opportunities are not. With that, I have an incredible guest today, and I want to welcome all of you to GSD Presents Top Global Startups, where I sit down with founders building the technology shaping how the world actually works. Today's topic is one every CEO, COO, and supply chain leader is feeling in their bones. How do you make high-stakes decisions when volatility is constant, not occasional? From geopolitical shocks and climate disruptions to supplier fragility and cost whiplash, supply chains are no longer linear systems. They're living, adaptive networks. Joining me today is Evan Burkosky, CEO and co-founder of Kimaru.ai, a deep tech company building what they call supply chain decision intelligence. Kimaru's patented causal engine and decision digital twin technologies are focusing on accountable, explainable decision automation, helping enterprise leaders move from reactive firefighting to confident, data-backed decisions. Evan has spent years applying AI and machine learning to drive real logistics optimization, procurement savings. And today we're going to unpack what causal AI really means, why traditional predictive models fall short, and how global leaders, can actually trust AI in high-stakes environments. With that, I'd like to welcome Evan to the show. Hi, Evan.
Hi, Gary. Thanks so much for the opportunity. It's really great to be here.
So everyone talks about supply chain uncertainty, but you talk about constant volatility. What's fundamentally different about the world we're operating in now? And from your vantage point, what's the biggest mistake enterprise still make when trying to use AI for supply chain decisions? So first is, what's fundamentally different about the world we're operating in now?
Well, I think everybody feels it. It's a time of constant volatility, whether it's constant, tariff changes and adjustments, changing global weather patterns, global conflicts, the pandemic, even, big ships getting stuck in the Suez Canal a few years back. There's constant change. People in supply chain might have one of these events like once in their career normally. Now it's happening constantly. It feels like every month.
Yeah, so from your vantage point, what's the biggest mistake enterprises still make when trying to use AI for supply chain decisions?
Well, the biggest mistake is using tools that were built for predictable patterns. We used to be able to look at seasonality, look at, our data, our systems of record, our spreadsheets, and then a good planner could use their judgment. And even if something changed, they'd have options. They'd know how to map that out. But today, the disruptions are so complex. Even if they've got good experience, got a good map, they just don't know which route to take.
Kimaru focuses on decision intelligence. How is that different from traditional analytics or predictive AI?
So decision intelligence, it's like an operating system for complex decisions. What it does is provides a methodology to essentially create, first of all, a world model of your actual supply chain and all these physical constraints and trade-offs. And then it gives you the methodology for mapping out actions that are actually within your control. The methodology was created by Dr. Lorian Pratt. She has about 30 years of consulting with large clients on these type of really complex decisions. And she created a really handy methodology called the causal decision diagram. It takes basically your desired outcomes, maps out what's within your control, what isn't. Once you have that map, then you can start building this world model to run simulations on.
You built a patented causal engine. Can you explain in simple terms why causality matters so much in high-stakes supply chain decisions?
Yeah, absolutely. I think the best analogy is that map analogy. So let's look at a causal AI tool that pretty much everybody uses today. Google Maps or your car navigation. right? So the way that Google Maps works is it has the physical map, understands all the different routes that you can take, and then it measures congestion and disruptions essentially, and basically uses that disruption metric to provide alternative routes. And that's exactly what we're doing in supply chain. So we're saying, is this storm, is this ship delay, for example, is this going to cause a little ripple that affects your supply chain, or is that going to expand into a big tsunami? So it could be, ship delays, it could be, labor disputes, it could be tariff changes, all of these little disruptions, and they're happening constantly. Is it going to turn into a big disruption or not? So going back to the map analogy, is a little fender bender going to clear up quickly, or is it going to cause a massive gridlock that's going to have the whole city shut down?
Where do purely predictive models break down when leaders are dealing with procurement, logistics, or manufacturing trade-offs?
There are a lot of good systems, a lot of good tools that people have been using for years. Systems of record, ERP, supply chain planning systems, SCM software, but they're deterministic by nature, right? And so the way that type of AI works is like a business intelligence tool or an analytics platform. It looks at historical patterns and then projects out from there. So what we're doing, Causal AI, is more like prescriptive analytics, where it doesn't just project out where you're going to be in a few days or weeks or months. It tells you what actions you can take to actually control where you want to be. So looks like this is where we're going to be. We want to be here, runs scenarios and models, and then gives you options for actually getting there.
Let's talk about trust. This is the biggest thing. I was with one of the regional persons from Palantir a few days ago. Trust, empathy, compassion. I mean, it's we don't have those systems today, right? And
yeah.
So people are nervous because you don't know. The system is on one side. In fact, I was just with one of my buddies from Africa, and we had that exact conversation too.
Mm-hmm.
How do we know that these systems are really looking out for our best interest, right? When you start using pragmatic decisions, that may not be something that's interesting for humans, because that may be diametrically opposed to who we are. So how do you make AI decisions explainable, accountable enough that a COO or board will actually rely on them and not think that they're hallucinations?
Yeah, well, that's the critical thing, right? And trust is critical on several levels. So first of all, you have to be able to trust that the AI, the agent or the system you're using, understands the physical constraints, of your business. So we start with essentially, what's being called a world model. In our case, that's like the nervous system of sensory feedback, both from your internal systems. This can be like production line uptime or warehouse capacity, things like that, combined with external signals. So again, kind of the nervous system extending out into the physical world. So we're pulling in data from shipping information or weather information or tariff changes, Commerce Department updates, things like this. And then all of that's combined into this physical world sensory feedback. And then we can run simulations and kind of dream different counterfactual scenarios, which is what's required for causal AI. But to put it in really relatable terms, it's the way we think. This type of essentially digital brain is trying to emulate organic brains as we're trying to build intelligence. So the best way to build that is using something like you may have heard of Daniel Kahneman and Amos Tversky's thinking fast and slow, system 1 and system 2 thinking, right? So, we've got the kind of bottom up limbic system, which is like reactive, and then we've got the top down, more rational system, right? You could also think of it in terms of the actual left brain, right brain hemisphere, the way we actually work. So, generative AI, the stuff that's in the news all the time right now, LLMs, that's more like actually a dreaming state, or, let's say more conceptual thinking. It's not grounded in reality. And that's why we get hallucinations, because it literally is like the way we dream about stuff. But if you combine that with a physical world with constraints and actual sensory feedback, then you get the correct left brain, right brain balance. And that gives you this grounding so that you're actually running simulations and then getting recommendations that are grounded in reality without hallucination. But without that embodiment, LLMs, they're an amazing tool, but they can just make stuff up. So they need that physical world grounding.
Now, it's interesting. I mean, so we get down through and if you look at it, what mindset shift do executives need to make to move from intuition-based decisions to AI-assisted decisions that are going to help them?
Well, the key is this decision intelligence methodology. So, if we look at, first of all, the history of that methodology, Dr. Pratt created it as a scalable, repeatable system. And you can do it on the back of a napkin. So you can map out, these causal factors in an analog way. What we've done is productize that and then build it into the world model so we can run simulations. But that, first of all, gets everybody aligned around the decisions and their constraints. So let's think about a practical example of a decision constraint. Say you've got a sensitive product, maybe pharmaceuticals, and you've got a shipment en route. You're expecting them at a certain time, but there's a storm, there's a disruption, and so the ship has to be routed around the storm. If you've got like a generative AI-based system, it might have the creativity to route the ship to another port and maybe even direct a truck to go meet it there. But if it's not grounded in the physical world, including constraints like regulatory constraints, it might divert that ship to a port that doesn't have clearance for that product, say pharmaceutical product. I'm actually speaking of a real world use case here where...
Well, that's what I was going to ask you, what does it look like in the real world, not the marketing version, right? And it's one thing coming into that port, but what if it's a port where there's a bunch of pirates waiting for you?
Yeah.
Nothing good, right?
Well, there's a pretty famous use case in the industry where AI, this type of generative AI, actually did route a ship to the wrong port. It didn't have clearance. The product couldn't be unloaded. It had a shelf life. About $1.6 million of product was lost, right? So a major mistake. Now, one way to build trust into the system is to use decision intelligence that's grounded in things like regulatory frameworks. So you've got that, let's say, operating system that understands where the ship can actually be routed to. The other thing is to always, our system is completely human in the loop, decision augmentation, not automation. So the primary pain point that we're solving is the decision bottleneck. So we remove all of the manual processes around getting data into the system and then modeling out complex decisions. So we automate a lot of those processes, removing all that manual stuff that slows people down. But then every final decision is reviewed by the human user. So there's culpability and traceability. This is really, really important, right? So the way our system works is every decision is recommended. The human either accepts or adjusts that decision, and then implements in the system, and it's tracked. There's a snapshot of that, a decision receipt, right? So that builds trust into the system as well. A good way of thinking about this, actually, let me tell you a little bit more about the story of how we built this, because I think it's quite interesting from a management perspective. So the company's name, Kimaru, is actually the Japanese verb for to decide. So we took that name because we started in Japan, where in my previous work I'd been selling recommendation systems, these type of like product recommendation, mostly for e-commerce use cases. But then through consulting work and where I met my co-founder, it was more grounded in the physical world. And so we needed to find a way for maximizing like production uptime in manufacturing environments, this kind of thing. Japan's very, very good at extremely, high trust decision-making processes. Mm-hmm. There's a Japanese word called ringisho, where you circulate a document and all stakeholders sign off on that. And that's part of what's called a nemawashi process, basically stakeholder alignment process. Japanese governance is not top-down or bottom-up for that matter. It's kind of top-down, bottom-up several times, and then side-to-side across all the departments. So everybody gets aligned around a decision. Once everybody understands all the constraints, then they go ahead. So the decision-making process is like 80% preparation, 20% execution. So that's great. Sorry, lights are turning off here. That's a great way to make sure that your decisions are trustworthy. The problem is, in today's information age, that process is extremely slow. So the biggest problem in the Japanese economy today is with the declining workforce, the per hour productivity is actually slower than most other developed nations, partly because of this process. So we wanted to create a digital bingi show, essentially a way to do all the underlining work, get stakeholder alignment, and make it very quick to clear that bottleneck of the decision-making process. So that's where the name comes from, and that's also where the history of this type of system comes from, is basically trust-based decision-making.
So supply chains are non-stationary systems. Distribution shifts constantly. How do casual models age compared to predictive models in environments of continuous disruption?
Well, if we think about the involvement of these systems, the evolution of these systems, it starts with a deterministic system, and then you can get a probabilistic system where you're making forecasts based off historical patterns. But a prescriptive system like ours is one that understands, not just what the projection is, but what you can do to control that future outcome, and then run simulations to find out what is the best way to do that. So going back to that Google Maps analogy, say there's a traffic accident, this route is blocked off. The AI measures actually, real world, let's say real world feedback, because Google Maps knows every other car that's on the road right now in that traffic pattern. And then it feeds back how quickly they're moving through that system and maps out which is the best way to go. So our system does that too. We have essentially a feedback metric that's measuring disruption, and then what is the cause of the disruption, what is the best way to clear it. So in real time, in really volatile situations, we're using that disruption metric to figure out which is the best path to go. Of course, we have to run thousands of different simulations across all these different trade-offs. But once we've built out that world model and we've got this data with the correct sensory feedback, we can do that in real time. That's not something that a human can physically do. There's just too many variables to calculate. So we need AI for that assistance, but we need trustworthy AI that's built on a system that understands actual physical constraints.
Most enterprise, so I'm using multi-agent large language models now, kind of like my grandmother, and she's listening to our conversation, and now she's come up with some questions that she wants me to ask you.
Okay.
As most enterprise AI still optimizes correlations at scale, what kinds of systematic failures or systemic failures do you see when a correlation-based models are used to make irreversible supply chain decisions?
Well, first of all, the problem is the speed, right? Most of those models are operating on about a quarterly timeline, right? It's very, very difficult to deal with today's volatility. Let's say the example of a tariff change, right? When you're dealing with these historical models that are, quite long cycles, right? You need that real world causal feedback, that disruption metric, to be able to model things out in much shorter cycles, near real time. And then the other problem is just the data breaks down. It's historically, it's been very, very difficult to connect to all the requisite data and clean it correctly. We'll get 80% of the way there. Historically, you might have a lot of the factors that, would go into building out that simulation, but you're missing one critical thing quite often. So it's only in this agentic era where we can have multiple different agents going out, pulling in various data sources, triangulating, cross-referencing the data, using, a admin agent or super agent to arbitrate across all the different trade-offs, then understand which data is correct, normalize all of that, and then feed it into the causal model.
It's interesting. So she wants me to talk about this. This is what she's diving into. Your decision digital twins enable counterfactual analysis, asking what would have happened if. Why is counterfactual reasoning essential in supply chains where decisions can't be replayed?
Well, that's exactly it, right? So what we create, when I say a world model, it's this combination of real world feedback and constraints combined with a digital twin, a virtual representation of that, not just the physical world and your physical constraints and so on, but the options that you can take, right? And there, again, most decisions, there's thousands of different trade-offs. So the way that we build a causal system is using counterfactuals, right? The ability to imagine something that doesn't yet exist. I think it was in the book *Sapiens* by Yuval Noah Harari, where he talked about one of the great steps forward in our history was our ability to imagine counterfactuals. Like, I imagine that there's a lion hiding behind that rock, so I'm going to go the other way. This ability to create essentially an avatar of yourself, a virtual representation of yourself, and run it through scenarios that are potentially dangerous and kill off the avatar in that virtual representation so you yourself don't get killed. That's one of the amazing things that human intelligence can do. So a causal system, a causal AI engine like ours, has to run all these counterfactual simulations in a virtual environment so that we can then find the optimum action to take without product spoilage or without ordering the wrong thing, and making sure that you do balance across the right supplier so that your planning is correct. Because a lot of these, like you say, you only get one chance. You can't undo it if you're taking the wrong decision.
Well, can you share an example where the statistically optimal decision was actually strategically wrong?
Well, that can happen, and that's one reason why it's so critical to have the human in the loop, right? So let's go back to that. Well, actually, the example of the pharmaceutical shipment. That's an example where it wasn't our system. It was a last generation, let's say, deterministic system combined with generative AI. But the generative AI created this counterfactual of an alternative port that they could go to offload the shipment, but they were missing the actual constraint of the regulatory environment. Do you actually have the ability to offload in that port, right? So that went drastically wrong, and the human in the loop didn't exist in that system. They blindly followed the AI recommendation, and so they were unable to correct. What you want is a system that can make recommendations, but then they're checked with human judgment, and the human can override those. And it becomes a continuous learning system where the human and the AI are both sort of fact-checking each other, but also learning from each other, right? So in our system, if an incorrect recommendation is made, the human user needs to catch that and should catch that. They're culpable, they're responsible for catching that, overriding it, and then that trains the system so they don't make that same mistake again.
As AI begins to automate decisions rather than recommend them, who's actually accountable? The model, the data, or the executive who approved it?
Always the executive that approved it. Our system provides that culpability, right? Because it is a human in the loop system. But a critical part is this, what we call the decision tracker, that gives a decision receipt. What was the recommendation? Why was the recommendation made? Who accepted or who approved the recommendation? And then what was the outcome? So these decision receipts are time-stamped reports. They show exactly what was running at that time, what were the sensory feedback, data inputs, what algorithms were we using, how were we modeling out that scenario. And it's with the expectation that as AI becomes more and more prevalent throughout the enterprise, there will be cases where maybe big mistakes are made, and maybe it connects to a lawsuit or it connects to some sort of damage claim. So we have to be able to figure out who was culpable. And in a system like this, a true enterprise system, the AI is a tool. It's a very handy tool, but it's not the final intelligence. It's not the authority on the decision, right? So the same way, our laptop or computer here is an extremely useful tool, it's not responsible for how we use it. We are.
So, how should enterprises design governance frameworks for AI-driven decisions before regulators force the issue? Because it's going to happen, right? And then insurance companies come in and start with a liability situation because, if you're not paying attention and you're, driving a truck and you end up hitting somebody else, but you're not driving. Who's responsible? It's interesting. But how do we get down through and design the government's frameworks before it's a problem?
Well, that's specifically what we're talking about here. There already are frameworks. For example, the EU framework is providing us, the basic constraints around responsible AI use. We've built a system that gets way out ahead of that, or any other framework that could foreseeably come down the pipeline, by making sure that there are complete decision constraints, that everything's following these legal frameworks, that everything is glass box and reportable. Probably the best way to build this is to follow the expert advice of people like Dr. Lorian Pratt, who created the decision intelligence methodology. Her book, The Decision Intelligence Framework, is an excellent way to do this. And also Gartner. Coincidentally, just today, Gartner launched their first Magic Quadrant for decision intelligence. So you can see, if you have access to the Gartner report, you'll see precisely what these required features are. One of them is complete explainability. So these decision receipts, essentially, or complete auditable systems. That's a hard requirement for any software in the decision intelligence category. So any, let's say, Gartner-approved decision intelligence platform has that built in, and to sort of reduce the cognitive load of finding a good system, you could follow their recommendations. We've followed, very closely the work of Gartner's analysts as they've helped build out this category. And although we're still quite early stage as a startup, we're hoping to win a spot there pretty soon once the next one comes out.
And have you raised funding yet?
We're pre-seed. So I'm not sure if I can say how much we've raised so far, but
you didn't want to talk about numbers because we're broadcast everywhere. But I understand you're a pre-seed company.
That's right.
We're coming to the top of the show, and like I said, we can speak to you a little bit. Evan, after we're done, where can people learn more about your company and follow your work?
Well, please check out the website. It's Kimaru.ai, Kimaru. Or you can look me up on LinkedIn. I'm always happy to chat there. Evan Burkosky, I'm easy to find. I'm the only one on the planet with this name. So just Google my name or look me up on LinkedIn. Always happy to chat.
Evan, this has been a fantastic conversation. Decision intelligence is clearly becoming a board level capability, not just a technical one. And thanks for joining me on my show, GST Presents Top Global Startups. And to everyone out there watching, stay curious, stay adaptive, and we'll see you next time. Be happy, stay safe, and let's go out and get them. Let's GST. Thanks, everybody. And thanks for taking time as your busy schedules to join us today. Thank you.
Thanks very much. Thanks, Gary.